Good morning, students. Students, I expect that you are now familiar with the Newton's first law of motion, which states a body tends to remain in the state of rest or of uniform motion until and unless an unbalanced force acts on that particular body. That means, students, a body continues in the state of rest or motion until and unless we apply an unbalanced force. That means the unbalanced force can produce an acceleration in the body or change its velocity and change its state of rest or of motion. So, this Newton's second law of motion was being proposed to understand the force, the value of force, and how to calculate the force in terms of mass and acceleration. So, practically, it was found that the acceleration can be produced in a body if an unbalanced force acts on the body. Okay, now see in the figure. This person is applying a force on this trolley, and this trolley contains a carton which has a certain mass. Now, this person applying a force on this trolley, an acceleration is being produced. You can assume, you can experiment with any body. If you apply a force, a certain kind of an acceleration is produced in that body. Okay, so now you can understand this person is applying a force and the acceleration is produced, and that means the speed increases. We can understand that whenever a force is applied, some velocity changes or the speed changes, because of which the acceleration is produced. In this similar case, you can see when we apply a more force with similar mass, a more amount of acceleration is produced in the body. That means the speed increases faster. So from this we can understand that acceleration is directly proportional to the force applied on the body. That means if you apply a force on the body, acceleration will be produced. That directly means if the force changes, acceleration will change, and if acceleration changes, that means the force is also changing. Now, let's see, students, once again, on similar lines. There is the same trolley in which there was one carton initially, and we are applying a force and acceleration is being produced. Now, if we are using the same trolley for carrying different luggages for more number of cartons, that means the mass is increasing. Now the mass is increased. If you apply the same force, the acceleration produced will be less. You can easily experiment it. If you carry a heavier luggage with any vehicle, the acceleration or the speed of the vehicle is slightly decreases. The speed increases slower. So in this way, you can understand that with the same force, if the mass is more, there is an acceleration, and if the mass is less, there is more acceleration. That means we can understand that the acceleration is inversely proportional to the mass. That means, see in this relation, that acceleration is directly proportional to 1 upon mass of the body. अगर mass increase हो रहा है तो acceleration decrease हो जाएगा, क्योंकि अगर हम बड़ी वैल्यू से डिवाइड करते हैं न्यूमरेटर को तो छोटी वैल्यू आती है, अगर छोटी वैल्यू से डिवाइड करेंगे न्यूमरेटर को तो बड़ी वैल्यू आएगी. ठीक है ना. सो मास ऑफ द बॉडी क्या है, अगर ज्यादा है तो एक्सेलरेशन कम है, और मास ऑफ द बॉडी अगर कम है तो एक्सेलरेशन प्रोड्यूस क्या है, ज्यादा है. एंड इफ वी कंबाइन बोथ द रिलेशंस, द एक्सेलरेशन विल कम आउट टू बी एज एक्सेलरेशन इज डायरेक्टली प्रोपोर्शनल टू F upon m. So in this way we can understand the force applied on the body is directly proportional to the mass of the body into acceleration produced in the body. Okay, now force is directly proportional to m into a, and if we remove this proportion sign, a constant must come, and that constant we are assuming as k, and so F is equal to k ma, and here k is constant. If we take the k as 1, the relation will come out to be as F is equal to m into a. That means the Newton's second law of motion can also be stated as the unbalanced force acting on a body is the product of the mass and the acceleration. Now, students, with the help of a train, a vehicle, this train and a wagon, we let's understand the effect produced on acceleration due to the changes in the mass and the force. Suppose we are taking a one wagon in the first case and with the two engines. Okay, now these two engines are pulling this one wagon. The force applied by both the engines will be more, and the mass is slightly less. So the acceleration produced will be a bit larger, because the large force, small mass gives large acceleration. Now, if we remove one engine, that means the force applied is a bit less, but there is same wagon, one wagon, the acceleration will be a bit lesser as compared to the first case. Okay? Now in the next case we see third case, there are two engines and there are two wagons also. Now the mass is also increased, and the force is also increased. The large force, large mass, but the acceleration produced is a bit less. Okay, you can calculate it by putting various values. You will find out the value of acceleration very easily. Now students, if we remove one engine and if we apply, if we use the two wagons, if we are using two wagons, there is same mass as in the previous case, and the engine is less. There is less force because of one engine, but the mass is more. So the small force but large mass gives small acceleration. So in all the three cases in the bottom, from the starting the second, all the masses, all the acceleration produced was in all the three cases less, but in the first case acceleration was large because the force was applied was a bit larger and the mass was a bit lesser. So now I think you must be able to understand the relation F is equal to ma, and the acceleration of acceleration with mass and force in a but more easier manner. So please students, watch it attentively, listen attentively, and if you have any queries, ask me. And please test it, try it at your home also. You can easily experiment various objects by moving it, by applying force. So you can observe how much acceleration is produced, and you can calculate and perform an activity based on it also. Okay students, thank you very much. Thank you.